continuing on with factoring, we're looking here at our perfect squares. Now, these last two types we actually can treat as simple or tricky trinomials. We don't actually have to know these perfect squares. Difference of squares is a little bit more helpful, but if you recognize some patterns happening, it can make the process go a lot quicker. So a perfect square have a perfect square as the first term and as the last term of the quadratic. So I've written over here some of the perfect squares, the first 10 perfect squares. These are numbers that you can square root and get a nice whole number for them. So 1 squared is 1, 1 is a perfect square. 2 squared is 4, 4 is a perfect square. 3 squared is 9, 9 is a perfect square, and so on. So if you look at the first example here, we have a 1x squared, so that is a perfect square. We could square root that and just get x, and on the end we have a constant of 25, which is also a perfect square. So when we go to factor it, we square root, so my instructions are up here at the top, we square root the first term, so the square root of x squared is just an x, and we square root the last term, which is 5, and we take the sign from the middle. So we've got a plus here, so the plus goes here, and then we make that to the exponent of 2. But the last thing we want to do is double check it to make sure it actually equals the original binomial. If I were nice and wrote that out twice, so what I'm doing in green here is just writing it out twice to check, and then I'll show you a shortcut to this. So if we expand this, we're going to have x times x, which is x squared, which is my first term, that's good. And then we have x times plus 5, which is plus 5x. And then we have plus 5 times x, which is another plus 5x. And then 5 times 5 is plus 25. And when I collect these like terms, notice that we get exactly the same thing happening, and it happens twice. So our product of x with the 5 is how we got 5x, and then we had that again, another x times 5. So it's really these two terms multiplied together, x times 5 is 5x, and then doubled to give us a 10x. And that's our middle term. Whoops. Okay, and plus 25. So this did work. The quick way to check is back here. If you take the product of x times 5 and you double it, x times 5 times 2, that gives us 10x. We're checking to see, is that the same as what's in the middle here? And it is. So we know that our factored form is correct. But we do have to check that if we're using this shortcut, because it doesn't always work out to be this way. All right, the next one. Square root the first, that gives us 2x. Square root the last, the square root of 9 is 3, and take the sign from the middle. And then I'm going to check it. So in green I'm checking here. I'm going to have my 2x times negative 3, and then I have to double that, so times by 2. And when I do that, I'm not sure how I keep moving my screen around, but I keep doing it anyway. There we go. So 2 times negative 3 is negative 6. Negative 6 times that 2 is negative 12 with a multiply of x. So that did work out, and I just need to make sure I put a square on that bracket. Okay, so it's 2x minus 3 all to the exponent of 2. Otherwise, I would have to do that as a tricky trinomial, where I'd find two numbers that add to negative 12 and multiply to 36. And that's going to give me a negative 6 and a negative 6. And then I could do my decomposition like we did in the last video. All right, part C. The first term, perfect square. Last term, perfect square. I'm going to square root the first. I get 5x. If I square root positive 9y, I'm going to get 3y. Sorry, positive 9y squared. Square rooted is 3y. And take the sign from the middle, which is a plus. And then I'm going to do my check. 5x times 3y doubled. That's 15xy, double that, that's 30xy. Yep, it does work, and I just need to remember to put my square there. Okay, the last one, perfect square, perfect square. I'm going to square root the first, I'm going to square root the last, and I'm going to take the sign from the middle, all to the exponent of 2, and then I'm going to check it. If I do x times negative 4 doubled, that gives me negative 8x. Uh-oh. So this one is an example of where it looks like it could be a perfect square, but it actually turns out that it's not a perfect square. So what we're going to do now is erase that. Erase, erase, erase. Come on. Apparently I can't erase that little last part, but that's okay. we'll work with it. This actually is a simple trinomial. So I'm going to go back to my adds 2 and multiplies 2. I'm looking for two numbers that will add to negative 10 and multiply to positive 16. And my brain was thinking faster than what my hand could write. I think negative 8 and negative 2 will satisfy that. And because it's a simple trinomial, we can go directly to the factored form. X minus 8 times x minus 2. Okay, not actually a perfect square. All right, so those are perfect squares. Our differences of squares is when we have a perfect square take away a perfect square. So let's go to the next page here. So I'm going to write that in as my statement up here, plus when I go to factor it, it's similar in that we take the square root of the first. So we're going to square root the first. We're going to get a 2x. I'm going to square root the last. We get a 5. And then we have two binomials that are going to look almost the same, except one has a plus sign and one has a minus sign. These are called conjugates of each other. They look the same except opposite signs in between. If I were to expand and simplify that, 2x times 2x is that 4x squared that we needed. A 2x times a minus 5x gives us a minus 10x. But then the plus 5 times the 2x gives us plus 10x. So the opposite signs are what cancel these out and or undo each other and leaves us with no x term in our answer. And the last part of this is plus 5 times minus 5 is the minus 25. So that's where we get this perfect square minus the other perfect square. The middle terms cancel each other out. All right, so I'm just going to summarize differences of squares here, and then we'll do the next examples. Okay, for our next example here, we have a 36, which is a perfect square. Square root 36, and we get 6. So 6 goes at the beginning of our two brackets. Square root the x squared, it came second, so it has to go at the ends of the brackets. And then we make one a plus and one a minus. And these could be in the other order in terms of it could be 6 minus x first, and then 6 plus x. But we don't want to switch the order in the bracket. We don't want to change that to an x minus 6 and an x plus 6 because the x squared has to end up being the negative. Okay, now part G, I forgot to reset my number counting here, so my letter counting, this could have been A, B, C, D, but it's E, F, G, H because it continued on from the one above. Square root the first term, we get 7x. Square root the last term, we get a 4y, make one a plus and make one a minus. Okay, so the only difference here is we now have an extra y squared at the end, which just means we have y's with the 4. All right, the last one gets a little bit crazy in terms of we've got this whole thing squared. So if I square root that whole thing squared, the square root and the square undo each other. So at the beginnings of my brackets, I should have an a plus b because that's the square root of my first term. And then I square root the last, which would be 2, and we make one a plus, and we make one a minus. So hopefully that all makes sense. I'm going to throw another example. I may as well follow my numbering here. We'll call this I. I'm going to do one more similar to part H, but I'm going to flip it around the other way. All right, I'm going to make this 25, take away a minus b all squared. Okay, so I've switched a couple things here. When I look at this, I do have a perfect square minus another perfect square. I'm going to square root the first. It goes at the beginning of my bracket. Notice I'm leaving more room for this. I'm going to square root this last, which will be a minus b. I'm going to put that inside another set of brackets because what happens is we have to make one plus and one minus, and while the plus makes no difference, this will just be 5 plus a take away b. Here on the second one, that minus 1, we're minusing both things in the bracket. So now we have a 5 minus a, and then minus times a minus will be plus b. So this would be our final answer in simplified form. So hopefully that makes sense for you.